Welcome to this presentation on VR modeling for the automotive industry, where I'll talk about typical current workflows and some of the issues related to that, and how moving towards VR concept modeling can address these issues. My name is Nick Graveley, and I've had a 20-year career in clay modeling in the automotive and motorcycle industries. I've been aware of the trend in the wider automotive industry of a steadily shrinking demand for clay modelers. Whilst every studio has a different workflow, the trend has been to do more of the creative concept modeling in packages such as Blender or Alias, and then use clay modelers simply for cleaning up milled clay models rather than the actual creative work for which their skills have been honed. In 2017, I got my first exposure to virtual reality when I saw the scan of a full-size clay model I was working on dropped over the engineering package and rendered in VRED. With the correct color breakup and the reflective surfaces, I could identify several issues that weren't apparent to me in the clay, and I understood that as soon as we could create and edit in this VR environment, it would change everything. That change came in 2020 with the introduction of the Oculus Quest 2 VR headset, with a low enough price that meant I could afford to experiment with the recently launched sub-D functionality of Gravity Sketch to model in VR. Now, having seen how effective VR modeling is, I'm driven to share it with the rest of the automotive industry, where I can have a positive impact on both the future careers of design modelers and the bottom line of these companies that embrace it. There are big changes happening in the automotive industry, such as the move to electric drivetrain and autonomous vehicles, which has led to the rise in so-called challenger OEMs that are exploiting these opportunities and harnessing new processes to develop vehicles in half the time of incumbent OEMs. To remain competitive, there's pressure among these incumbent OEMs to cut development time and costs and to increase profitability. Part of this process has been to identify and reduce capital or time-intensive development processes such as clay modeling. So whilst the need to review a design as a full-size physical model remains, the push has been to take care of the design development digitally. In addition to this, customers are demanding not just great products, but great product experiences, which calls for much closer interdepartmental collaboration during product development. The design process that we have today is the result of an ever-evolving process. For almost a century since the first clay model was built in GM, the design process has adapted to harness new technologies and ideas. In the 80s, with the inception of Alias, the idea of design modeling digitally started to become possible, with much wider adoption around the start of the new millennium, with faster and cheaper workstations available. The use of digital modeling has steadily grown, and the price of doing so has reduced significantly. In parallel to this rise in digital development, clay milling and 3D printing technology has advanced to give better and faster methods of manifesting digital data for review in the physical world. With the rise of these two technologies, the reliance on labour-intensive design development in clay has reduced significantly, and by integrating the design development with other digital processes, such as engineering, has brought significant advantages. From sketching to engineering to design modelling, we've seen that one by one, processes that were done manually have become digital. The trajectory is digital, and the opportunities for advancement are in improving the ways that we use digital tools. Until recently, the state-of-the-art digital interface was a 2D monitor. In the last couple of years, VR headsets have added depth to create a much more advanced interface. Today, the most widespread workflow seems to be to develop concept models on a 2D monitor and reviewing in VR before milling a full-size clay model, where the designer and clay modelers have a limited window of opportunity to refine the design surfaces before diving back into the 2D CAS for further development. The problem with this 2D to 3D process is articulated beautifully by Achim Anscheid, design director for Bugatti.
You were looking at a CAD screen, but what you saw then in the yard was different. All of a sudden the sunlight hits this thing and looks different, and you go around it in 3/4 view, and things are not the same way as you saw it on the CAD system.
So we've got this 2D digital creation process, which is removed from the 3D review process. We're creating 3D objects in a 2D environment, and so we're only discovering 3D problems once we bring the data into 3D. As a result, we're doing many loops of back and forth from 2D to 3D as we zero in on the desired design. Furthermore, whilst we benefit from the significant advantages of working digitally, it has come at the cost of many of the benefits of physical modelling. The designer now no longer has a true understanding of the 3D form, so makes inadequately informed decisions that are now conveyed to the modeler through sketches and verbal descriptions, as opposed to, on a physical model, getting a true sense of the model's three-dimensional form and giving concise feedback directly on the model through knife and tape lines. Clay modelers, once revered as an indispensable part of the creative process, are now relegated to cleaning up milled data. The understanding of surfaces and proportions that skilled clay modelers have built up over tens of thousands of hours sculpting real things in the real world is irreplaceable. 2D CAS modelers are less likely to have this background, and not leveraging these 3D modelers' skills is to the detriment of the final outcome. Limiting 3D review to occasional review sessions in VR and then infrequent clay instances doesn't allow for the designer to just sit and be in the presence of the latest model, to really live with the design for any period so they can really understand what the form is doing and so make informed decisions on what it should be doing. The solution is to shift creation back into 3D, and in doing so reconnect the creation and review processes. Once the key 2D sketch is agreed, all further development work should happen in 3D. The latest generation of VR headsets, already trusted for 3D review, now have software such as Gravity Sketch that enables this 3D creation. Studios need to reignite the effortless collaboration between designer and modeler that happens in 3D space, redeploying traditional clay sculptors who can use their particular skills to now handcraft digitally. VR modeling is not a replacement for clay models. However, it is the natural next step for some digital modeling, specifically complex surface models, for which clay would have traditionally been used. Clay models still have tremendous value in the process, but once trust in the VR output has been established, they can be used more as a verification step towards the end of the design process, where only small surface refinements are necessary. Craig Dent of Ride Studio is one of my pioneering clients who has fully embraced VR modeling as part of the design process. A lover of clay models, he's seen how VR modeling has filled the perceptual void that exists in traditional 2D CAS modeling.
I was pretty skeptical of how the clay would come out. And a week later, visiting you in your clay workshop and seeing a milled clay in front of me that was shockingly close to the perception that I had in Gravity Sketch, I couldn't believe the speed in which we were able to turn traditional sketchwork, emotional sketchwork, into emotional models that you could interact with fully.
What this graphic is showing is a subjective analysis of how the different processes compare for different factors within design development. Clay modelling, here in red, scores well on 3D specific topics such as model presence and the designer's ability to understand the form, make decisions and communicate with the modeler. However, it falls down on its high cost and slow speed and ability for other stakeholders to cooperate. 2D CAS, here in blue, scores moderately everywhere, except for 3D form understanding and designer-modeler communication. Whereas VR modelling, here in yellow, scores very highly in all factors, offering the fastest project at the lowest cost. In fact, VR modelling actually offers all the benefits of digital modelling with all the benefits of clay modelling, whilst largely negating the downsides of each. According to leading consulting firm Kearney, styling development time can be reduced by over 50% if VR and AR processes are adopted. Correspondingly, project costs can also be slashed by over 50%. Designers can make more informed design decisions through being able to see their design in true human perspective at one-to-one, with the correct colour breakup and referencing technical requirements, then communicate these design changes through precise 3D lines that are analogous to clay tape lines. Getting collaborators around a model at the same time is no longer a challenge, with remote access through secure servers. You likely have clay modelling resources that would welcome the opportunity to reskill and future-proof their careers, whilst getting back into the creative driving seat. Let me share a brief explanation of my workflow for going from 2D sketch to a 3D model with Gravity Sketch. To start, I'll position the design sketch over an imported package data at 1:1 scale. I'll trace over the 2D design sketch's major surface breaks and silhouette with curves, and this converts the design sketch into a 2D line sketch. Then, using supporting sketchwork and referencing the technical requirements, I'll edit those 2D lines in only the Y direction, the axis parallel to the wheel axle, to form a 3D line sketch that maintains the side view design, but also now considers the design in 3D. Each of the lines in the resulting 3D line drawing represents a surface break, an intersection between two adjacent surfaces. We can tune the position of each of these lines relative to one another by inferring the surfaces that span between them. Once we are happy with this network of curves in space, we can go ahead and create surfaces, being careful to lay out the surface topology in a way that reflects our design intent. Once this first interpretation of the sketch is in, we have an excellent starting point for the designer and I to start working together in a way that feels very similar to clay modelling. He can judge the design in front of him as if the model were truly there, and draw lines and notes in the air, or directly reach in and start pulling around surfaces that I then subsequently clean up. Sub-D modelling with Gravity Sketch offers great speed, flexibility and collaboration. It's perfect for the early and intermediate stages of concept development, where the ability to respond rapidly to new inputs is more important than perfect surfaces. Modelers can be trained to build models with optimized topology, which results in very acceptable surface fidelity. The data can be output as OBJ, FBX, or IGES, allowing it to be directly milled, or it can be thickened in Gravity Sketch and 3D printed. There are challenges in adopting new workflows. However, hopefully by now you'll agree that VR modeling is an essential addition to any concept development workflow, and that these challenges are worth overcoming. Data security is always a top issue, so whilst Gravity Sketch can be run entirely offline on a standalone computer, you'll want to have the option to work online with others in the same collab studio. For this, the studio is run on Gravity Sketch's TSAX and DCSO certified secure servers. ISO certification is expected in the summer of 2023. VR hardware and software is required. Many studios already have VR hardware, and Gravity Sketch itself is available for free, with the option to upgrade to an enterprise license. To integrate VR modeling into an established process should be relatively straightforward. It can be simply substituted in place of whichever tool is currently used to create digital concept models. Imported reference data should be converted to OBJ format, but otherwise the process of going from sketch to model is not dependent on integration with other tools. The output files, OBJ, FBX, and IGES can be used downstream in the way as any mesh or scan data. Gravity Sketch is easy to learn. It's remarkable for its simple user interface, where endless menus and complex tool options are absent. Once OEMs start to adopt this, many more clay modelers will pivot and learn VR modeling, creating a virtuous cycle. I'm highly motivated to create a brighter future for clay modelers. What are the next steps you can take towards an effective 3D digital workflow? Talk about this with your colleagues and strive for consensus that 3D creation in VR offers real advantages over the current workflow. Acquire hardware and install Gravity Sketch for free. Then we can arrange a live demo. I've used Gravity Sketch for everything from sketch concept to A-class data review. However, if in doubt, start small with concept modeling before deploying VR in more diverse ways. Perhaps run a small proof of concept project. You provide the sketch and I'll provide the modeling services, so you can witness firsthand the extraordinary difference in model quality achievable by handcrafting digitally in VR. And the last step would be training of your workforce in Gravity Sketch, which I can of course help with. My course can be taken by anyone with zero prior experience in VR or digital modeling necessary. This immersive training happens entirely online in VR. We need to strive for continuous improvement and innovation. VR modeling is not the end. This is just the most recent evolution in the workflow. As VR and AR hardware becomes higher resolution with larger field of view, we can expect a greater experience of immersion and presence with the model. Also, AI will soon be capable of generating meshes from text and sketch prompt, but to what level and how this is harnessed remains to be seen. The future is unknowable, but change is inevitable. Thank you very much for your attention. I hope you found this presentation informative, and if you're ready to move forward with VR modeling or have any questions at all, please don't hesitate to contact me.